Hi everyone, this is Alessandro De Maria from Kapitan.dev. This is another video, second video that I will be creating to explain a little bit a more advanced use case for Kapitan. In the specific, today we are going to use, we're going to configure Loki, the log based system based on Grafana, the Grafana Loki. And we're going to use Helm charts to install it, and we're going to discover some capabilities that you acquire when using Kapitan instead of using vanilla Helm. I must say that I don't normally use Helm in its kind of a standard form, so you will see me reaching out for help or to instruction how to operate the Helm side of things, but I will show you how easily it is to integrate with Kapitan. At the moment there are two ways to deal with Helm charts within Kapitan. So you can, if you go on our website, which is kapitan.dev, and you look at the documentation, you will see that one of the input types is the Helm type, and we are going to basically have a look at this first and configure this to start with using this approach. In this approach, we're basically using Kapitan to use its built-in capability of dealing with Helm. However, what I want to also show you today is the ability that we've added to what we call Kapitan generators, which is like almost like a way to add a extension or easy to configure extension and plugins to Kapitan. We're going to use the Kapitan templates approach simply because I think that makes it a little bit much easier, and it acquires some properties that you wouldn't be able to have with the vanilla installation of Helm, with the vanilla support of Helm for Kapitan. But let's get started in a way. So we will see exactly how we configure Loki. Okay, I have a version of Git pod installed in my Visual Studio, and I already have checked out the Kapitan reference, which is what I suggest everyone to use at least at the beginning to get familiar with all the different kind of concepts. If you want to start from scratch, one of the opportunities you have is to delete all the targets we have and start from scratch. Otherwise, there is also on the website other ways to create a more clean setup. For the time being, I'm going to use what we have here, and I'm going to create a new file, and so a new target file under the inventory targets, which we're gonna call perhaps Grafana, because we're gonna use Loki anyway through the Grafana interface. So let's call it for now Grafana, and we will add the component Loki to the Grafana target. So I'm going to create a grafana.yaml, which is going to be like an empty target for the time being, and we are going to use the most basic kind of approach with the most basic kind of a boilerplate, which is going to include adding classes, and then we usually add common, which brings in the most basic aspect of for Kapitan that is needed for having a working target. So already now, if we run first of all git diff, we can see, or git status, we can see that only the new Grafana target is being detected by Git as untracked. If I run Kapitan compile, and for the time being I'm just going to use the -t that allows me to select a specific target I want to compile and say Grafana, so that I can compile only this specific target. With a bit of luck, I should see that we are downloading the for the first time the generators from the Kapitan repository. This happens automatically. We are going to compile Grafana. The download of the generators is simply happening not because we create this file, but simply happening because In the current setup that we have, these generators are defined, but we don't kind of supply them directly with the Kapitan reference repository, so that the first time you run, it will basically also fetch the newest version from the Kapitan generators website. But as you can see, if I run it again, that kind of bootstrap won't happen again, and you will only be compiling Grafana. If I do git status now, I can see that as expected, we have a couple of extra. So first of all, we've imported now the generators that were downloaded from the generators repository. You can see there are two, one for Terraform and one for Kubernetes. We can also see that in the system libs, we have a couple of extra kind of files that have been updated, because perhaps, you know, when we've done the first fetch, is the genlib is also defined as a new file, so that is detected as a file that updates it to a new version. And we can also see that in the compiled Grafana folder, we now have a folder with some manifests, just a namespace for the time being, and some basic script that gets installed every time we do a Kapitan compile. So I'm going to start by creating a folder, Loki setup, a branch. We're going to add all these files, initial target created. Okay, so this is like the very kind of beginning of our path to understand how to configure Loki. For the time being, we have just one target file called Grafana. We've simply imported the common boilerplate class that allows us to have access to the most basic Kapitan configurations. Now let's look at the documentation for Loki. We can see that they are providing a Helm chart available for us, and you can see that the normal commands to install under Loki is to add the Grafana repository, and then basically there will be some other things that are needed for, to be honest, this is where my understanding of Helm stops. But all we need to do is basically be able to tell Kapitan where to fetch the chart, what kind of chart we want to download, and what version of it, right? So I don't think I have Helm installed at the moment here, so we need to first of all install Helm in our Gitpod environment. So let me go, and this is like a step that is only needed if, like in this case, we want to understand a little bit more about how Helm works and how to configure, but it's not needed by Kapitan per se. So let's go and search for it and install Helm Linux. So we can see the installation directory. They advise you to, because we live on the edge of technology, we are just going to do the same installation this way, which is something I don't never recommend you to do it anyway. So now we have Helm, and we can start continuing on with the setup we have on Grafana Loki. So let's add the Grafana repository, and then I believe there is Helm repo search. No, there is going to be repo. Here you go, we have Grafana, but if I want to see the what's inside, I'll have to. Here you go, I'm back. As I said before, I had to understand how to do things with the Helm. So the command is no Helm repo search, but is Helm search repo Grafana. So once we run the Helm search repo Grafana, we can see all the charts that are available under the Grafana repository. And the one we're going to work with today is this Loki distributed, which is the one that we want to install. and you can see there are two values associated with it. One that specifies the specific chart version, so we're gonna use the latest one, and the same thing for specifying the app version associated to that kind of chart, right? Okay, so now that we have these two values that are available for us, we need to tell Kapitan how to first of all fetch that specific Helm chart and make it available to the rest of Kapitan, and then also how to compile that specific chart as well. So at the moment I'm doing everything within the Grafana target. We will relocate this configuration later into a class component. For the time being I'm going to write parameters and then I have a version where I can cut and paste from another folder, another window, so something that I have already kind of created. You can see that I'm defining here some basic parameter for Loki. This is more of a standard pattern that we have within Kapitan, so we define some sort of a variable associated to this Loki setup, and we're gonna call some variables that then we will reuse multiple times. So at the moment I'm just defining all the different kind of things that we want to reuse. I'm defining the chart version 0770, like we said here, and the version is 292, and for Loki distributed is 292. Okay, so and also the name of the chart is called Loki distributed. So at the moment I kind of have all the variables that are needed for me to kind of reuse and to use within Kapitan. This is not doing anything at the moment. I need to add instruction to tell Kapitan how to fetch the chart and how to compile the chart. So when I fetch the chart, first of all there is a capability within Kapitan which is to download dependencies. So you can access it by cutting this kind of a specific format structure. Kapitan dependency of type Helm, so it's able to detect that the dependency is a Helm chart, so we have that kind of a native support within Kapitan. And then you need to pass a couple of values. So the output path, I'm reusing this chart there. We tend to kind of build, you can decide how to organize your charts within your repository, but we tend to install under system sources charts, and then we use a combination of chart names and chart version and Loki version to application version to select which subdirectory we want to install the chart within, right? So if I now run this command, as you can see, chart version and chart name are being passed on. What is going to happen is Kapitan is going to fetch that file for those kind of the chart for us and download it and make it available for us. Now you can do this by running again the Kapitan compile Grafana. Normally you would need to run with the command fetch. However, in this installation I've configured the .kapitan file to fetch by default, as you can see here in the .kapitan file, which means that it's not strictly needed, but just to make sure that you don't get caught by this kind of issue, I'm going to write here in the command line, but it's actually not needed. So if I run Kapitan compile Grafana fetch, it will download the chart for me and make it available in the directory that basically is represented by this chart directory. Okay, so if I do now git status, I can see that the system sources charts Loki distributed is now also available as an untracked folder, and I'm going to add it to Kapitan. So I'm going to do things step by step so you can see all the different kind of aspect of this configuration. So git commit add chart folder. Okay, git status again, and we are okay to go. Now, so far we've only basically downloaded the dependencies. Now we need to tell Kapitan that we want to compile that chart. And in order to do this, we are going to now use as I said before, we are not going to use the built-in support that we have for well, actually we can do that as well. So if we go and look into the we can first do it for the built-in support, and then we can look in migrating to use the generator. So if you look at the documentation, you can see that what we expect is to have a compile a compile section under Kapitan, and we need to pass some specific parameters. So I'm just going to copy and paste it here, and we are going to use as output path dot, which means it's going to be installed within the subdirectory of the compile folder for the specific target. Input type is Helm. Input chart, because we have the directory here, input chart is going to be the Loki chart there. The values, we are going to, at the time being, leave it as a empty value. And Helm params, we're going to pass the Loki chart name, and then if there is a Loki namespace, it's not here, we're going to say assume that we want to have installed in the same namespace that is globally defined for this target, which is going to be Grafana, the name of the target itself by default. And again, we're going to say here that namespace is going to be Loki namespace. So let's see what happens if we now run Kapitan compile. We can remove the fetch. We know that we don't use it anymore. Hopefully it will not crash. If it does, we'll try to understand what's going on. But basically what we've done here is we configured Kapitan to use one of the built-in input types of type Helm, and we've defined the path where to find the chart, the value files you expect to send through, and the Helm parameters, which are the minimum kind of set of things we need to pass to Helm to make it work. So if I now do git status, I can see that in the compiled Grafana, now there is a Loki distributed kind of a subfolder, and you can see that within here we have all the different kind of sub configuration that we have for Helm available. So we have config map, we have for Loki. So we have a distributor, gateway, ingester, queryers. So these are all kind of sub-components that gets deployed by this chart with some configuration like a service account and so on. Okay, so now we're gonna see immediately one big difference between using this system and using the other kind of system that we're gonna move into now by using the generator. And it's the fact that when we deal with, when we use the input type, the Helm input type, we kind of subject to the organization of the Helm chart that the way it came, the Helm chart that we received. So the subdirectory that we create is going to map exactly the kind of subdirectory that you would have for the Helm creator. The Helm chart creator intended it to look like. So you can see that you have the distributor will have a deployment and service, gateway will have all these kind of other files available. But in this case, let's say that each chart will generate a structure that it may be kind of drastically different from one to another. It's just at the moment this is just a minor aspect, but I just want to point this out because you will see how things change when we actually use the generator. Okay, so at this moment I've compiled the file, the Helm chart, so I'll add it and commit to say compiled chart with native Kapitan approach. Now, with the native kind of Kapitan approach, obviously you pass Helm values. At the moment, this is an empty Helm values, but the right way to handle it would be to create a Helm values here, and basically start passing parameters we might want to change by then referring here to Loki Helm. Okay. So just to make it sure that it works, I'm going to pass now a special key that we know that the chart for Loki supports, which is going to be the full name of a ride. Somehow I don't like the fact that this is called Loki distributed. I would prefer it to just be called Loki. I don't care whether it's distributed or not. So turns out, and maybe there are other ways to make it work, but this is probably the correct way to have it to change the name in a way. Or at least from the content of the objects, because if I look at service distributor here, you can see that the instance name is called Loki distributed, and I don't like that. I think changing this chart name will require changes in many other places. So again, this is one of the parts where I admit the fact that I haven't used Helm a lot. But anyway, it's still worth to see what happens when I configure this Helm value. So I'm going to run Kapitan compile again, and now we're gonna see that there are gonna be some differences in these files that get created. Status. Yes, you can see that the files haven't changed, like the Loki distributed subfolder hasn't changed. So this is still reflecting the kind of Helm chart that you're receiving, that you are downloading. But if you look at the config mouse standing here, you can see that some values, like the name of the objects, have actually changed to be just Loki. So in this case, it's kind of nice because the chart still reflect the fact that this is called Loki distributed, but at least the name of the Loki distribution is matches something that is more nice to look at. So I think we are okay from that kind of. This is also showing one of the benefits in using Kapitan, because now we are able to see the differences that were created by making this change to the Helm values, but just looking at normal git diffs. So if you were in any other setup where you're using Helm and you're applying Helm directly, yes, you can decide to render the templates all the time, but this is not something that is built in and to any specific kind of workflow associated to Helm, not that I know of. So Kapitan kind of forces that kind of approach to be much more visible. So every time you make a change, you can actually see the configurations changing with you. Now, in the case of the Loki the Loki name, this obviously creates many changes that might be a little bit kind of even difficult to kind of evaluate effectively. So this becomes much more helpful where you're making like a Helm upgrade, or you're looking at changing just one, something that is less of a impactful, but it's still good to see exactly what's happening in this case. So I think I'm definitely happy with the fact that the change that was created reflects what I wanted to achieve, and I will be adding this and commit, say change name of Loki deployment. If there are better ways to do it at Helm, to be honest, I don't know. Feel free to comment or let me know, but for the purpose of what I want to do, I think this is just to show how to influence the creation of the Helm chart by passing some arbitrary Helm values, and we will look at a lot more about it. So for now, just stay tuned and wait while I continue with this tutorial. Now, as I said before, what I want to do is actually make use of the new support that we have of generators for Helm. The main difference is that while with the built-in support of Helm, we have no control over the generated files. We're just passing the value, the input values to Helm, and Helm will generate it for us. So following the same structure that the Helm chart was creating, by using the chart actually gives you some extra power that are only available through Kapitan. And so I'm going to show you now how to turn this configuration into one that uses the power of the generators for us, and hopefully we will start to see some benefits right away. So the change that we need to do at this point is to use a different kind of path. At the moment we're using Kapitan compile, and then we add in this as a list. What I'm going to do now is remove this altogether, and I'm going to paste the new structure. And the new structure is basically activating the generation of Helm charts by using this special key. And then we are going to define the name of the chart, the idea of this kind of configuration, which we're going to call Loki. Most of the configuration are the same. We have here the name Loki, which I think was just an attempt that I did in the other configuration to deal with the full override that we have here. I think normally we should just have this. So for now, I'm just going to revert it to what we expected to be the default. So it's compatible with the current way we've done things until now. And then again, values are being set up through this way. Now this output file is something that actually it's a little bit misleading. Probably we can even remove it, but we're going to see that the format of the files that get created will take a completely different shape, and it's up to you to then decide whether you like it or not. So I'm going to run Kapitan compile again. The workflow is always the same. You make one change, compile, look at it, diff, and add it as a commit. So you basically get used to the idea of creating micro changes that are very easy to kind of commit per commit, are very easy to understand what's happening. So I'm running Kapitan compile again. Hopefully it will work again. Here we go. Now, if I look at the status, I will see there are loads of changes now, because what has happened is that the new chart that deals, the new generator support that deals with Helm is able to read all the files that are being rendered by Helm, and we are able to basically import them into Kapitan, and basically we can decide where these files go. And this is the main difference. So I'm not subject anymore to the configuration of how the chart was created. I can make it map my way of how I want to handle different files, with different kind of files, which means that I can have, first of all, a very kind of standard way of bucketing specific components, specific files that might be helpful in the future. At the moment, I won't show you what is being, what we're using to basically change this configuration, but this is something we can discuss later. But what's happening at the moment is that the files are being read by Helm, and then they're being added into, the resources created by the Helm chart are being read by Kapitan, by the Helm supporter Kapitan, and written into files which are grouping by a specific kind of type. So we have a file called rback, a file called bundle, a file called config, and if I click into the bundle one, I can see that bundle one pretty much contains anything to do with workload related kind of things, so deployment and so on, while config will contain, again, config map, service, again, any service that is basically available within the Helm charts. Okay, we can actually configure where these files go. For the time being, we just take the default configuration, and we accept the fact that we've gone from having multiple files where you clearly have a visibility of the kind of component that they are inside, but technically they could have different kind of file, different format. In this way, I find it much cleaner, because it allows you to follow your own kind of structure for the files that get created. So, and okay, cool. Now, what we have now, so if I go back to this kind of initial setup, we can see that we have a very basic configuration. We have the bit where we download the Helm chart, the bit where we define the chart. So this is probably not going to change much in the rest of the conversation we're going to have. So we're going to focus now on how we influence the creation of the Loki chart based on past parameters that we pass through Helm values. So from this point onwards, I guess it's going to be more of something that will change depending on how the Helm chart, the kind of parameters the Helm chart allows us to send through. But one change we can do right away is to basically start moving all this kind of configuration. Rather than having it in the target for Grafana, we're going to move under a specific class. So what we could do is create a component class. Perhaps we can call something called a folder called Grafana, or even Grafana Labs. I think that's the name that they use for all the different kind of Grafana objects, and we're going to create a new file called Loki. .yaml. Okay, and what we're going to do is take all this configuration we've now defined in this file, take it from here and move it into its own configuration, so that we can declutter the Grafana target, which will probably become helpful in other ways, and we can have everything to do related to Loki into its own kind of class. We obviously need to do the final part of loading the new class with the within the target, so we can load components dot Grafana Labs dot Loki. As we move things around, but in a way without it actually altering the making any other change, what we expect now to happen when we run Kapitan compile is that if we done things properly, if we loaded the class properly, we expect no changes to happen at all, other than the changes to do with the inventory, because we just relocated the component with the inventory without actually changing anything else related to Loki and Grafana. So I'm going to add commit and say that we are relocating Loki configurations to its own class. Okay. Again, what I tend to do is always get to a point where you have a clean Git status, so you can make this kind of incremental changes in a way not to overcomplicate it. Even when it gets reviewed by other people, it becomes much easier to understand what's going on. So now, let's say that we want to start changing configurations about Loki. So at the moment, we can close the Grafana target. We can focus on the Loki class here. Let's see what we can do to somehow change some other aspect of Loki. So I'm going to now start copying configuration for what I have in the kind of other working example. So assuming that this is going to be deployed to a intend to use, I'm going to start making changes so that we can adapt it to that kind of. If we get to the point where we deploy to a local Kubernetes setup, it won't make much sense, but I just want to show you things little by little. So one of the things we can do is I like to take advantage of the opportunity that we have within GKE to use workload identity. So first of all, I want to be able to define a GCP service and be able to basically refer to it so that we can configure the proper authentication for it through the workload identity. That means that the components running for Loki in Kubernetes will be able to take on the assume the identity of a GCP service account. So from what I can gather from the configuration, we need to pass this kind of configuration settings here, which I'm going to now cut and paste. And so we have the service account definition where we need to pass a name, and we need to pass for our annotation, we need to pass like a service account, a GCP service account. So again, I'm going to basically copy this kind of fill in this kind of values with something that I have prepared earlier. And we're gonna say that the service account name, we're going to call it Grafana Loki. Don't have to, we can just call it Loki. And then the GCP service account that we want to create is going to actually, I need to call it Grafana Loki because Loki is too short as a name to be valid as a GCP service account. So let's call it for now Grafana Loki. And the GCP service account that we want to map and use is going to have the same name as Grafana Loki, and it's going to use the same project that is going to be defined within this kind of setup. Most likely this project is not defined yet, so this will fail. So for the time being, we are just going to define a Grafana Loki GCP project ID to make sure that it doesn't fail for no reason. We're just going to call it test. Yeah, so we define the name service account. This is the reason why we put it under this Loki sub parameters is because we want to be able to reuse these parameters multiple times. So we've created one defining just the service name, one defined the GCP service name, and we've injected this kind of configuration within the Helm values. So let's see what happens if from now we Kapitan compile again. Hopefully again we are not expecting any crash or anything, and it will basically render the differences. And if I do git diff status, first of all, you can see there are some changes happening in both the bundle and the RBAC files. And if I do git diff or compiled, you can see that the project is actually going to change to test. So I was incorrect here. We already have a file called GCP project which default to the target name, so we can remove this without fear. And then we are going to see that the service account name changes from Loki to Grafana Loki. This is the service account from within Kubernetes. What I like to match is to match the service account of Kubernetes with the name of the service account on GCP. That's why I think I'm still okay with the idea of using Grafana Loki, because Loki would be too short to be valid as a GCP service account. And then we can see that using the Helm chart support, so this is basically, so far we've seen all things that are available from the Helm chart. They made available this opportunity to basically add an annotation to the service account. So this is, so far we are benefiting from the fact that the Helm chart author thought that it would make sense to provide this kind of facilities. Okay, so I'm going to run a compile again because I've removed the project name. I've removed the override for the GCP project ID. So if I do a git status now, git diff, I can see that the only changes we see are the one strictly related to the service account. And so I'm going to add, and we're going to say that we have added service account definition. Okay, as you see, everything is very super incremental, and every time we make a change on Helm, normally if you had to change these values, you kind of need to imagine all the changes that would be affected by the template, unless again you render the template and you have a way to make a diff. But in this case, as soon as you make changes, you can immediately see what are the changes that are going to be affecting in the templated files, in the render file, and you can immediately understand what's going on. So this is something I like a lot about this approach of using Helm with Kapitan. Let's carry on and show now some other things that we could be doing. So there are other parameters we can pass to the ingester by all means. So one of the things that I discovered, as you can imagine with Helm, if you wanted to understand what else we can change, you need to go and look at the specific value file. So if I go into sources, charts, Loki distributed, and I look at the value file, I can see all the different things that I'm allowed to change in a way. And I need to understand each chart will be slightly different. So I need to understand how it works for this specific chart, and I need to understand how to add configuration changes in a way. Now, while I was configuring my setup, I was looking at ways to change the config file. That is going to be the config file for basically the main kind of Loki setup. And here's where we start to get into a point where, for me, Helm in a way falls short, and it's the fact that if the author of the chart thought about giving you an opportunity to kind of override some specific values, then it's good. Like in this case, you can see that it's giving you some values. So if I pass, if there is in the value file, in the Helm values, if there is a structure Loki schema config, allows me to override with that content, and I can make loads of changes that are possible because of this kind of specific configuration. However, I found myself in a situation where I had to change some stuff that was not kind of templated in a way. So immediately after building several different kind of types of configuration, for instance, even this kind of auth enabled equals false, it's not that's not what I was after, but basically turns out that that was not templated in a way that I could make use of it. And even the fact that this template file is actually not available as an actual file somewhere, I think it made it a bit difficult for me to understand how to make it work. This is surely, it's not a limitation of Helm per se. It's the limitation for me is the fact that the Helm chart author needs to make sure that all these kind of files are created in a way that is consistent across the whole setup, and if you have a Helm chart from two different kind of providers, they will be with slightly different value files, so you always need to work out which one is best in a specific situation. So in my case, I didn't want to kind of deal with this kind of complexity, and also I don't want to make changes to the value files in this specific configuration, because I don't want to touch the original files that were downloaded from the chart, so that in the future, if I do a Loki chart upgrade, I don't have to remember to make all the changes that I had to apply to hack my configuration in a way. So what I'm going to do now is I'm going to take advantage of the fact that at least this chart allows you to pass the full config file, the full content of the config, and so I'm going to inject the whole configuration into of what I expect it to be into this config file, so I don't have to deal with all this kind of this lack of different kind of setup. I will build that with the capabilities that are available within the inventory itself. So in this case, we are going to basically say that I'm going to override .yaml, and within this new file, I'm going to paste all the configuration that we have here, all the configuration that I want to basically override within that file. So this is now is going to become, it's going to take this kind of configuration and add it into the file without me having to worry about whether it's supported by the Helm chart or not. I can see that because I was trying to use the object store type GCS, there is only one parameter that I'm passing, which is the Loki bucket. We need to make sure that we add that Loki bucket definition somewhere. So in the class for Loki, generic class for Loki, we are now going to import from the classes file. We're going to import a file called configs/.loki. So this is going to read the subfile called Loki within the config subdirectory, and it's going to basically merge it with this configuration. So we don't need this kind of parameter here anymore. But as we said, we need to have something that contains a bucket name, and which in this case we're going to call it just GCP project ID _-Loki. So we expect the bucket name to have the name of the GCP project ID we want to associate it with, and then extra name called Loki. Yes, Loki storage perhaps. Okay, so what's happening now is that I've imported the Loki configuration. I've saved the Loki configuration I want to have into a file called yoki.yaml, which is plain inventory, which means I can use any kind of inventory parameter interpolation that I want to have within this kind of setup. And I've loaded a class into my configuration of Loki. So now if I run Kapitan compile, what I expect it to happen is that it's going to basically, it's called just bucket, no bucket name. Yeah, what I expect it to happen is now it's going to replace the content of the config file that will normally be generated with the one that I'm passing entirely. So if I look at the bundle, the config setup, you can see that some things here have changed. Specifically, we can see that we've added a bit related to the GCS bucket. So again, it's very easy to understand what's happening here. Very easy to see the changes that have been introduced. You can see that nothing else changes. It's just this kind of small kind of other values that are being changed. Something else I will see is that in the bundle, it will basically reflect the file that the checksum for the config has changed, and so it will allow us to understand that this specific deployment needs to be restarted. Okay, so here we are. Let me see. So I'm going to add commit added parameters to config file, and we are yet again very incrementally we've been come up with a setup that already allows us to have a good grip and configuration of Loki. Now, just as we allow 15 minutes in, I don't want to go past show you something else we can do with Kapitan, which I think is where it kind of sets everything apart in terms of configuration. So at the moment here for Loki, we defined parameters for the Loki chart. We defined the dependencies, so how to download the Loki chart, the information how to compile the Loki chart. And here are all kind of these are all Kubernetes related kind of changes, right? So we've generated file in the compiled folder that have to do with the specific configuration of Loki. But we might want to also start to incorporate other kind of changes that we will need in order to be able to set up Loki. Because in a normal situation, you need to create a bucket, and you need to create the GCP service account, and you need to give it permissions. So in a normal setup, in a normal kind of setup where you don't use Kapitan and you don't use that kind of power, you are basically only able to alter anything else within your setup. So I'm going to now start copying some other kind of bits of configuration related to the generator's Terraform setup, which we also mentioned here that is available within our capabilities. It's not defined, it's not helpful in any way because we haven't, we're still in a situation we haven't documented it properly. But I'm going to show you like a preview of some components that we can do, some things we can do within Terraform that hopefully will work if this version of if there is a basic setup within the kind of depository that will allow us to compile properly. If it doesn't compile properly, you will still get an idea, and perhaps I can address all the different changes into another video. But let's start with the service account. So I want to be able to define from here a service account. So what I'm going to do is using a Terraform setup, and this is where, let's see if it fails, because I haven't used this, I haven't done this part of the demonstration yet. But using the Terraform generator, I can say that I want to use the generate Google service account kind of support. Service account is going to be called Loki. Account ID is going to be based again with the service account. So the name of the service account will be consistent across Kubernetes and GCP. Very quick description just to show what it is. And what I'm going to do here is I'm going to tell the service account that I also want to create a special binding that allows me to use the workload identity setup that I want to set up for this Loki. So time of truth, let's see if it fails. It might fail for a number of reasons, because here we go, because there are some aspects that have not been defined. So in this case, the workload pool is not something that we have defined. So I'm going to just add a quick one just to make it sure that it works. So workload pool is usually detect it automatically based on the cluster where you are going to define it to. So because we haven't defined a cluster, that's why I cannot find the workload pool. Well, we're going to call it cluster project test for the time being. Let's see if we can continue with this demo. So workload pool in workload identity is just a way to define what's kind of the identity associated with the workload identity. So it has compiled. So we this is we went further out than further away than we were was expecting. We can see now in the Terraform folder. You can see now there is a JSON representation of what you would normally define using HCL that contains the service account and contains the information about creating the Google Service Account AIM binding. Now, I love this because it means that within the same kind of file, I can start to define bits that represent different aspects of the configuration. Not only the bit related to Kubernetes, but also the interconnection with the bits that are related to the generation of GCP services in this case, but could it be one to code into the specific generator. So at the moment we only have a bunch available, and as you can see, they also haven't been kind of documented very thoroughly, but you can see the power of having to have one place where you can define files that get generated for different subsystems. So what we're going to do next is also say that we want to create the service account. So a specific bucket. This is something else we need to see if it works. Gen Google storage bucket will create a storage bucket, again called Loki, and the name is going to be Loki bucket. So we are going to make sure by referring to this variable that there is a sync happening between the config file and the actual file being generated by this setup. Location here is hard-coded to EU. We can pass in. And this is basically another way to define a binding directly on the bucket, where we say that the service account, Loki GCP service account, is actually able to connect to this bucket. Now, given that service account is being created by Terraform directly, we could also use the other setup of using a reference to Terraform so that we can chain these two events together. We use a standard defining kind of a relation between them, which would be gen, and this is where I won't be able to test this anyway because I don't have there, but I can say Google Service Account.Loki that defines the resource I want to relate this kind of value to, and I think there is something called email. So in this case, I'm basically using Terraform to match the fact that when I want to have I want to use the email that gets created by the specific service account, which is a neater way because it also means that this object will be only created and after created. So if I do Kapitan compile again, I can see that there will be some other changes in the Terraform configuration. You can see that the bucket is being created. Now the bucket is being created with all the instruction we gave. There is kind of relation to the Google Service Account Loki emails that is being kind of defined, and this will be picked up by Terraform. This is like a Terraform interpolation of variables, and then you can see that again the service account is as we expect it to be. There is also the setup for the workload identity that picks out automatically the namespace where the software is being deployed to, and the service account, Kubernetes service account, to map to the specific service account ID. Okay. I think this is all. Normal way that you would test the Terraform setup would be to say compiled Grafana scripts Terraform, but as I said, because this is not being defined, I won't have it here, but I will leave it as a cliffhanger, as a teaser for a next video where I can explain a little bit more how it is the integration with Terraform. For now, the take home is the fact that we have created a class where we are able to define every single aspect associated to the configuration of Loki, including the potential need to set up resources that are outside of the configuration of Kubernetes, like in this case Terraform related resources. This is all kind of clear and visible within just one file, and it's definitely better than, for instance, having a setup where the value files gets repeated multiple times and gets sorry, this is the wrong file. The value files, it becomes much clearer than having just a value file that include all these kind of different values with no actually understanding what they are referring to, or having to duplicate loads of these values because the same name is going to be reused by multiple different systems. I hope you enjoyed this video. Please let me know. This is one of my first attempt to write videos, so I definitely need to improve on their format, but for the time being I just wanted to make sure that I could share as much as possible with you. Leave a comment, tell your friends, and let me know if I can answer any of your questions by joining our Kubernetes Slack channel. Thank you.